Okay, so we've separated out our variables and we've shown that the different parts, the x and t parts, are both going to be equal to this constant k. And what could k be? Well, let's start with the simplest case. The simplest case is that k is equal to 0. And that simplifies things. So we end up with, if we take these equations on the right, so if k equals 0, we have that the second derivative of the x part with respect to x is equal to 0. And we also have that the second derivative of the time part with respect to time is equal to 0. Now, what these could be equal to, so what it's saying is that if you take the second derivative of our x part and our t part, you get 0. Okay, so it's pretty easy to come up with a function that gives us 0. So we can take x of x is equal to some constant a1 times x plus some other constant b1. Same thing for time. We'll call it a2 and b2. a2 times time plus b2. a1, b1, a2, and b2 are just constants that could take any value. It doesn't matter what they are because either way we get 0 when we take the second derivative. And let's just double check that. So if we take the second derivative, we'll just pick the x one. Double check that this works. Well, the first derivative of we'll do one derivative at a time. So the first derivative of a1x plus b1 is equal to just a1, and then the derivative of a1 with respect to x is equal to 0. All right, so this works. So the next thing we need to do is figure out what our constants are, and we can do that by using our boundary conditions. Okay, so we know our boundary conditions are that u as a function, when u is x is equal to 0, and at any value of time, it's equal to 0. And so we know that x0 times t at 0 has to be equal to 0, and that u at L and t equals 0. We know that x at L and t at any time, and this should be time here, will be equal to 0. All right, so this function t of t will in general not be equal to 0 because t increases with time. So that means that x of 0 has to be equal to 0 and x at L has to be equal to 0. And if we look at our original equation, well, the only way for that to be true is that just the x function for any value of x has to be equal to 0. So this is this is a solution. This is a solution that we have 0 times something. So basically our function is just 0. And so what this represents, physically speaking, is the string sitting still. So that is a valid solution. That will satisfy the wave equation, but it's really boring and not useful to understanding when a string does actually move and vibrate. So we call this, in mathematics, this is what's known as a trivial solution. It's correct but boring and not useful. So next video, we'll look at something that's more interesting and more useful.